Okay, so what we're trying to do is determine how much output a firm is going to produce given its input prices and its output prices, right? So the first thing to remember is that as we talked about in the first class of this unit, our basic premise is that firms are trying to maximize profits, right? So their decision is going to be made to maximize the profit as a function of their output, which is just going to be the revenue that they get given their choice of output, minus their total costs, given their choice of output. Right, so their ultimate objective is to make the difference between their revenue and their costs as large and positive as possible. Now, because we're assuming that firms are perfectly competitive, total revenue is very simple, right? All it is just going to be the price times the amount of output. Why is this? Because we're assuming that the firm can sell as much output as they want at the market price, P. Now, their total costs are also going to be straightforward now that we've already solved the firm's cost minimization problem, right? Because our total costs here, if we're trying to maximize profit, is going to be the cheapest possible cost of producing Q units of output, which is just our cost function that we figured out last time. Right, so once we have a cost function, our goal is just going to be to make the revenues we get, price times output, as large as possible relative to our costs, right, of producing Q units of output. Cool. So to think about this clearly, let's go back to an example, fairly simple example, where we have a production function like f of L and K equals L to the 1/2 times K to the 1/4, right? And we can have a wage rate of, let's say, 20, rental rate of 5, and price of output equal to 50. And we can say that in the short run, right, let's imagine in the short run we have our capital fixed at 16, so that our production becomes, right, L to the 1/2 times 16 to the 1/4, or just 2L to the 1/2. Great. So if our goal is to maximize profits, let's start by finding our short run cost function, which is going to be very straightforward, right? The reason it's going to be straightforward, we're not going to have to worry about isoquants or choosing our optimal levels of labor and capital, because capital is fixed, right? Our only choice is how much, when we decide how much to produce, we don't really have a choice. We're going to have a certain amount of labor that's able to produce a certain amount of output. In particular, right, we'll say that our output Q is just going to equal 2L to the 1/2, right? Or L is going to equal Q over 2 squared. And therefore our costs of producing Q units of output will just be WL plus RK, right? Which is going to be 20 times Q over 2 to the 1/2 plus 5 times, what do we say our capital was, 16, right? So our cost of production is just going to be given by 5Q squared plus 80. Awesome. And then of course our revenue, right, very straightforward, is just going to be P times Q, so 50 times Q. So to get a sense of these things, and to think about how to maximize our profits, let's graph our costs and let's graph our revenue. Say for Q, right, we'll have costs, which I'll do in red, that start at 80, right? If I don't produce any output at all, I still have to pay for my capital because it's fixed. And then they increase like this, right? Because this is a squared function, 5Q squared. So when I have, say, a Q of 8, I would be producing, or I would have costs of what? 8 squared is 64, times 5 is 320, plus 80, so that would be 400. Right? Point is just, we've got costs that are increasing at an increasing rate, which is another way of saying, right, we've got diminishing returns to scale, or diminishing marginal returns of labor. Cool. On the other hand, right, if we graph our revenue, it's just going to be a straight line with a slope of 50. Right, so it'll just increase like this At 8, it'll also equal 400, right? Because 8 times 50 is going to equal 400. Awesome. And then our profits, right, are just going to be the difference between the blue line and the red line. So if I'm producing very, very little output, I'm in bad shape, right? I'm making negative profits. If I produce a little more, I can start earning some positive profit, right? Bigger, 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 bigger profit. But eventually, if I produce too much, my profit gets really small again and in fact starts to decrease. In fact, starts to become negative. The reason for this, right, the reason that our profit grows as we increase output and then shrinks as we increase output is because our costs of each unit are increasing, right? Our costs are increasing at an increasing rate. Our revenues are staying constant. So there's going to be some point like this where we're getting as much profit as we possibly can, right? We're maximizing profit. And as we can kind of see from this graph, the reason that this point is going to maximize profit is because the rate at which our costs are increasing equals the rate at which our revenues are increasing right at that point, right? In other words, each unit of output we produced before Q star brought in more extra revenue than it brought in extra costs. But if we increased output past Q star, we'd start bringing in less extra revenue than we would be imposing extra costs. Another way of thinking about this, right, is we can define basically our cost per unit or our cost of an extra unit as marginal cost, right? Cost per unit, cost for an extra unit. Right, and that's just going to equal the derivative of our cost function. We can define marginal revenue. It's going to be the revenue for an additional unit. Is just going to be dP times Q. dQ is just going to equal P, right? Because the derivative of P times Q with respect to Q is just P. So essentially what we're saying, right, is we're saying that we're going to maximize our profits when the additional the cost of an additional unit equals the revenue from an additional unit, because at that point, we've produced everything, every unit that's going to make us a profit. Awesome. So in this case, right, when we have a cost equal to 5Q squared plus 80, we can calculate a marginal cost, which is just the derivative of this with respect to Q, right? Which is just going to be 10Q. So if we think about this graphically, right, basically what we're saying is, if we've got Q here, we have marginal costs that are increasing. We have a price that's constant at 50. And our goal to maximize profits is to produce here, right, where marginal cost equals price. So we can say MC of Q is going to equal price. 10Q equals price. Q is going to equal P over 10, which is 50 over 10. So Q is going to equal 5. Right, so we'll produce 5 units of output. Why is this our optimal choice of output? Again, right, we're really saying the same thing on this graph as we did on the last one. Our first unit, right, only cost us a little bit. It brought in $50 of revenue, worth producing. Cost less than revenue, cost less than revenue, worth it, worth it, worth it, worth it, worth it, worth it, worth it. Up until we hit a price of 5. If we produced another unit, right, if we produced a 6th unit, the cost of that 6th unit would be greater than the revenue we bring in from that 6th unit. So essentially when we produce a quantity of 5, we've made every unit of output that we can make money on, and we haven't produced any unit of output that we would lose money on. Okay, so there we go, right? We're in business. If we have a cost function, all we have to do to find our optimal output, right, is to find where marginal cost equals price, and at that quantity, where marginal cost equals price, we'll be producing our optimal output. There's just two little wrinkles and caveats that I want you to focus on for a minute. So the first is, if we look at our cost function, 5q squared equals 80. When we took the derivative of this, we got a marginal cost equal to 10q. So did this $80 play any role in determining our marginal cost? Let's say instead I'd set, let's say our cost function had been 5q squared plus 1,000. Our marginal cost would still be 10q, right? Nothing would have changed. Now the reason for this is because that cost there, that 80, was the cost of our capital, right? The cost of our 16 units of capital. And because we're making a decision in the short run, our decision about how much output to produce doesn't have any effect at all on how much capital we buy, and therefore doesn't have any effect at all on this cost of capital. We're paying that $80 whether we make 1 unit or 1,000 units. And as a result, right, that $80 can't play any role at all in our current decision about how much to produce, because it's not affected by that decision. So this is a concept that we call sunk costs, right? This cost here is sunk because we can't control it with the decision that we're making right now. And economists believe if you're making rational decisions, you should always ignore sunk costs. From a personal perspective, right, this doesn't often seem right. This isn't what we do in real life. But this is what a rational actor who's making the best decision for themselves is going to do. Because the decision of output doesn't play a role in that $80, that $80 doesn't play a role in our decision of output. Great. The other wrinkle I want to throw in here is, let's say that I had a marginal cost curve like this, and a price like this. Am I going to want to produce where price equals marginal cost? Think about that for a second. So you're tempted to say, yeah, right, price equals marginal cost, just like our optimal choice here where price equals marginal cost. But in this case, we lost money because our costs are decreasing, our marginal cost is decreasing. We lost money on early units, right? We lost money on our first and second and third and fourth and fifth unit. This is all losses. And so if we stop right when marginal cost equals price, when marginal cost is decreasing, instead of, right, in this case what we did is we produced every unit that made us money and stopped before we started losing money. In this case, we would have produced every unit that lost us money and stopped right before we started making money. So the other rule we're going to have to put in place is we're going to want to produce where marginal cost equals price and marginal cost is increasing, right? So where marginal cost hits price from below. So if we imagine, right, if we've got a firm that has increasing returns to scale, right, decreasing marginal costs like the one we're drawing, if those costs were eventually going to go up, right, let's say the picture looks like this. We would want to produce here, not here, right? Because at this point, we've produced all the units of output where we can make money and stop before we start losing money. Cool? Great. And of course, if this never happened, right, if marginal cost never went up, they just stayed low, we would want to produce essentially infinite output if we could keep selling at a price of P. And in that case, we wouldn't be modeling the problem as a competitive markets problem, because firms would want to get as big as they possibly could, and they'd likely ultimately be limited by the size of the market. We wouldn't have a large number of firms producing identical output, because one firm could have lower costs by producing everything themselves. Great. So in our next video, we're going to talk about a bigger picture version of this question. So up till now, we've asked the question, how much output ought we produce? In the next video, we're going to ask the question, can we determine whether it's worth producing at all?